Hello everyone, I am Dr. Chander Pawar, working as an Associate Professor in the Department of Chemistry at Marri Laxman Reddy Institute of Technology and Management, which we call Mlritm. Today, during last class, we were discussing about cement reactions followed by the smart materials, different smart materials. Why we are calling them smart materials? What are the types of smart materials? And their applications, various applications, defense sector, energy sector, biomedical applications, etc. So today's topic is something related to extension of smart materials, few couple of slides, and then we will be moving for the lubricants. Okay. Now let us see here, which is shape memory alloys, which is SMA. So which is part of smart materials. Basically, smart material or SMA, shape memory alloy, is a material that remembers its shape and can be made to return its original shape after being deformed when subjected to heat. Okay, that means with respect to the temperature, upon applying the temperature or heat, what is happening? Material is changing. Okay, it's changing its shape, and upon removing the temperature, it is going back to its original position. So that is the main definition of shape memory alloys. Okay, for example, there are pens, two types of pens. When we press, there will be a spring and we will write, and once it is done, we will click on once again. Then what will happen? That a refill will be going inside. So now here, whatever the tic-tac pen, that is the best example for the shape memory alloy. Why? Because when we apply the pressure, the spring will be compressed, and when we do the second press, the spring will be going to its original position. Okay, when we apply initial pressure, spring will be compressed, and when we release the second click, the pen refill will be, that spring will be extended. Now here, when we click second time, spring is going to its original position. That means spring pen, ball pen spring is best example for the shape memory alloy. Now here we can see, it remembers its shape exactly. There is no alteration in the shape. Okay, shape is remained same based on some any external stimuli, like it could be heat, it could be pressure. So it is going for some shape change, but upon taking away those temperature or pressure, it is going to its original position. That is why shape memory alloys. Alloy is nothing but mixture of metals. For example, we know that for bikes we use alloy wheels, okay, which is rust free, which is more strength than the normal tires. So alloy is nothing but mixture of elements or mixture of metals. In Hyderabad, there is a Midhani, Misra Dhatu Nigam Limited Corporation. Okay, Midhani. So that is the institute which deals about metallurgy related materials. Metallurgy is nothing but composition of materials or metals. Okay. Now alloy means mixture of metals. Okay. Shape memory. Shape memory means they are remembering their shape. That's why shape memory alloy. Okay. Now deformed shape plus heat, original shape. Okay. Upon applying the heat, it might be deformed, but when we take away the temperature, it is going to its original position. That's why we are calling it as a shape memory alloy. Okay. Now nitinol, nickel and titanium based alloy is the best example for the shape memory alloy. What is the example? Nickel plus titanium. This is called as nitinol. Nitinol. Okay. This nitinol is the best example for the shape memory alloy. Okay, sorry, shape memory alloy. sorry. So now here we can see shape memory alloys are two types. Okay, first one is one-way shape memory alloy effect, two-way shape memory alloy effect. What is one way? Shape exhibit memory effect upon heating. Okay, one way means upon heating it is changing the shape. Two way, let us see, exhibit shape memory effect upon both heating and cooling. Something like we discussed thermoplastics. Thermoplastics, what is happening there? Upon heating it is becoming soft, and upon cooling it is becoming rigid. Rigid is nothing but hard. Similarly here, two-way shape memory alloy, what is happening? Exhibits shape memory effect upon both heating and cooling. That means while heating it might be changing, changing means shape is deformed, but upon cooling it is going to its original shape. That's why it is two-way. This is only one way. Okay, two types of shape memory alloys. The most widely used shape memory alloy material is nickel titanium, as I wrote earlier, and that is called nitinol, nickel titanium alloy. Best example for the shape memory alloy. Nitinol has excellent electrical and mechanical properties. Okay. Now let us see here. There is an example. Martensitic phase of a alloy. Upon heating, it is converted into austenite. Initially, it is martensitic phase. When we apply the heat temperature, it has, phase has been changed into austenite, and upon cooling this austenite has been changed into again its original phase, that is nothing but martensite. This is the best example for the shape memory alloy. What is the best example? Martensitic phase change. Okay, martensitic phase change upon heating, martensite to austenite, upon cooling austenite to martensite. So it's going to its original position. This is the best example for the shape memory alloy. Okay. Now there is this, another example, spring or any rod, when we bend it is going to its original position. Okay, so that's also comes under shape memory alloy. Now, applications of shape memory alloys. What are the applications? Shape memory alloys have applications in industries like medical field, mending bones, stents in arteries, eyeglass frames, tooth clips, etc. Here we can see not only medical applications, military applications, safety applications, robotics. Okay. Apart from this, dental braces, dental wires for the clips, dental clips. Okay. And it will make misaligned teeth gradually to original shape. Okay, we all experience in the day-to-day life, many people are using these dental clips to align their tooth properly. Okay, so there are shape memory alloy application in the dental field. Shape memory alloy used as a blood clot filters. Okay, blood clot filters. Clotting means forming lumps. Okay. And shape memory alloy used in automatic springs. Yeah, as I told you, pens, Tic Tac pens, Kit Kat pens. Basically, when we apply the pressure, it goes to compressed, and upon removing the pressure, it goes to original position. That's also a best example for automatic springs. Okay, this is about shape memory alloys. Now, shape memory materials, polymers. What is the polymer best example for shape memory material? Polylactic acid, PLA. PLA is the best example for the shape memory material or shape memory polymer. Now, polylactic acid denoted as PLA, thermoplastic polyester with backbone of C3H4O2 taken N. N represents number of monomers involved in the polymerization. Okay, thermoplastic polyester. Thermoplastic, as I told earlier, while ago, thermoplastic is nothing but upon heating it will be becoming soft, and upon removing the temperature or cooling it is becoming hard or rigid. That is the characteristic of thermoplastic, and this PLA comes under thermoplastic polymer as well shape memory material. Okay, now let us see. So here we can see what is the lactic acid. First, polylactic acid made up of what is the building block? Lactic acid is the building block. What is the lactic acid formula? CH3CHCOOH, and here there is a hydroxyl group. 1, 2, 3, 4. Yeah, this is lactic acid monomer. Lactic acid monomer. Polymerization. followed by the, it's a condensation polymerization. See, there is a byproduct, water molecule removal. So condensation polymer followed by the preparation of polylactic acid. Okay. Now, what are the applications of this polylactic acid? Transportation department widely we use. Agriculture department sector we use it. Packaging materials we use it widely. And biomedical industry we use drug delivery, etc. Cancer treatment. And electronic industry, why? Because polymers are best insulators, so electronic industry also we use. And textile industry also we use polyesters. Okay. Textile means garment factories. Okay. These are the applications of polylactic acid, and this is one of the best example for the safe memory alloy. So what is the best example for the polymer, best example for safe memory material? So polylactic acid is the polymer which is having safe memory alloy material properties. PLA is biodegradable polymer derived from renewable sources like corn, starch, topeka, sugarcane wastage. Okay. So these are the some of the sources for the preparation of polylactic acid. Okay, let's go. Now, advantages of polylactic acid. PLA stands for polylactic acid. Polylactic acid is thermoplastic polyester with backbone of this formula C3H4O2, and PLA is biodegradable polymer and basically derived from the corn, starch, topeka and sugarcane wastage. PLA had highest consumption volume of any bioplastic across the world. Based on its biodegradability and safe memory material, this PLA is widely used polymer across the globe. Okay. So PLA emits less toxic fumes than oil based plastics. Yes, that's also one beautiful characteristic of this polylactic acid. PLA melts easily because it has lower melting points, and PLA is compostable. Easily it can be degradable. It can be easily smashed. Okay. Now applications of PLA. PLA is most widely used plastic filament material in the 3D printing, carpets, clothing, fibers, packing material, medicinal implants. Okay. Medical, drug delivery, any other utensils or coating. So this is one of the best applicable biodegradable polylactic acid. Okay. Now here we can see another topic is lubricants. Lubricant is nothing but any substance which reduces friction between two moving objects. Okay. So when we rub, here there is a young boy rubbing his hands. What's happening? Basically in winter what we do, we rub the hands. Why we are rubbing hands? To generate the heat. Okay. So here rubbing means there is a friction between two palms. Okay. Due to that friction, what is happening? The heat will be generated. Now let us see. Young boy rubbing his hands which generate heat due to the friction. Okay, that's a general concept. Whenever there are two moving objects in the machinery, okay, so there will be a heat generation, and due to that heat, that machinery will be damaged. So to avoid that friction, we are using lubricants. What kind of lubricants? Here we can see most widely used lubricant, castor oil. There are so many oils. Disclaimer, I am not advertising for any commercial things here. Castor, to understand BTech students, best example is castor. It's a best example. What it does? A substance which reduces the friction between two moving objects. Gears, especially here we can see there are two gears moving and they are in close contact each other and they are moving, and due to that close contact there will be a friction and it will be damaged easily. So to avoid the damage or breakage of that machinery or these gears, we will be applying the lubricant. What lubricant does? It avoids friction between A and B objects. There are two objects A and B, gears are any moving or sliding objects. So due to close contact, friction will be generated. Friction is nothing but heat generation takes place. Due to that heat, what will happen? That machinery or that gear will be damaged. So to avoid that, we are adding the lubricant. Okay. Now, A substance which reduces the friction when introduced between two moving or sliding parts of machine is known as lubricant, and phenomenon is called lubricating. Yes, we all know that lubricants everywhere, in for bikes, for cars, for motorcycles, definitely there will be engine oil. We call engine oil, gear oil. Without this engine oil, gear oil, we cannot operate the machines, engines. So that is the purpose of lubricant, to avoid the friction, to damage or breakage the machineries. Now, lubricants are categorized into three types: liquid lubricants, semi solid lubricants, solid lubricants. Liquid lubricants are, okay, what are the examples of liquid lubricants? Liquid lubricants are animal oil, vegetable oil, mineral oil, petroleum oil blends. Semi solid lubricants are petroleum jellies. Solid lubricants are graphite and molybdenum disulfide. Molybdenum disulfide. Okay. Graphite is nothing but carbon allotrope. Like fullerenes, graphite is carbon allotrope. That's also a grease or wax we can use for the anti-friction agent. Okay. Now, lubricating, here lubricating oils or liquids classified into three types: animal oil and vegetable oil, basically whale oil, seal oil, mustard oil, cotton oil, etc. Okay, that is animal and vegetable based oils. Mineral oil and petroleum oil, these contain 90% of base oil and 10% are additives. Basically, I will tell you one generally here. If in winter, generally what will happen, due to lower temperatures, the parachute or any other coconut oils which we apply on the hairs, that will be becoming solid, that means frozen. So to that coconut oil, if you add at least 10 ml or 5 ml or some quantity to parachute oil or any coconut oil with other any oils, you can avoid the freezing or solidification of that oil. Here it is same, mineral oil. If you add 10% other additives, then we can avoid the freezing or its solidification of oil. Blend oils. Blend means mixture of oils. What are those mixture of oils? A single oil does not possess all the good qualities of lubricant. Yes, that's why to improve the lubrication quality, there is a need to add the additives. And what are those additives? Vegetable oil, coconut oil, fatty acids, palmitic acid, stearic acid, oleic acid, etc. to be added. Then we are making as a blend, and these blends won't be solidified easily. Okay. Now, a good lubricating oil must have following characteristics. What are those characteristics? Lower vapor pressure. For example, due to high vapor pressure, if we don't close the petrol tank lid properly, petrol will be easily evaporated. Why? Because it is highly volatile. Similarly, here, if your lubricant is having lower vapor pressure, that is nothing but it should have high boiling point, then we can avoid the volatile nature or its evaporation. So lubricant should have high boiling point, it should not be easily evaporate. Adequate viscosity. Viscosity is nothing but flow of any liquid. So lubricant should have adequate viscosity. That means it should not be too much solid, it should not be too much liquidous. Okay. Low freezing point. For example, in some countries like Canada or any other countries, temperature is going behind minus 40 degrees centigrade. And if your lubricant in the machinery, car engine, is frozen, there will be a trouble, car won't be started. So in such lower temperatures also, your lubricant should be in the viscous state. It should not be frozen, it should not be solidified. So lower freezing point, your lubricant should have lower freezing point, it should not be frozen easily. Okay. High oxidation resistance. Oxidation, if there is a oxidation, then corrosion will take place. Corrosion means deterioration of material, it will degrade. Okay. So high oxidation resistance should be there. Heat stability. When we run a car for prolonged time, 100 kilometers, 200 kilometers, 1 hour, 2 hours, what will happen? Engine will be heated up. Engine heated up means what? Whatever the lubricant, gear oil, engine oil is there, that will also be heated up. So in that case, your lubricant should be stable. Okay, heat stability should be there. Non-corrosive property, corrosion inhibition. Your lubricant should be corrosion resistive, or corrosion inhibitory properties it should have. Stability at operating temperature. Sometimes we will be going by using car for several hours. So at such high temperatures also lubricant should be stable. There should not be any evaporation. Okay, and sealing agent, it should be properly sealing, acting as a sealing agent. So these are the very important characteristics of lubricant oil. Okay, now here we can see first one is liquid based lubricant, second one is semi solid lubricant or grease. We all know that tractors, bikes, chain applied with this grease to avoid the friction. Okay, so grease is a semi solid lubricant obtained by thickening liquid lubricating oil through the addition of metallic soap. What is grease basically? Caustic soda based grease, lime based grease, lithium based grease, barium based grease. Now I will ask you one thing. Lime, which is something related to calcium oxide, lithium, it's a metal, barium, it is a metal, caustic, something related to sodium. So what you conclude here from here? That means grease is nothing but sodium, calcium, lithium, barium, metal based viscous material. Okay, now how this grease is prepared? The process called saponification. What is the process called? Here I have highlighted. Saponification of fatty acids, vegetable oils with alkali. Lime is nothing but calcium oxide. Caustic is nothing but sodium hydroxide related. Followed by adding hot lubricating oil under the continuous agitation. Agitations are nothing but sonication or something disturbance, vibrations. Okay, and the thickness is usually sodium, calcium or lithium soap as gelling agent. Okay, what is the role of these metals? As I told, calcium, sodium, lithium, barium based, it is these metals are acting as gelling agents. Viscousness of the grease is due to these metals. Okay, now third one is solid lubricants. What are the examples of solid lubricants? Graphite and molybdenum sulfide, disulfide. Graphite is nothing but carbon allotrope like Buckminster fullerene C60. We call it as a Buckminster fullerene. C60 is nothing but Buckminster fullerene. Buckminster fullerene and another is graphite. These are the carbon allotropes. Okay, and second one is molybdenum disulfide. These are the two examples for the solid lubricants. What is the solid lubricant? Example is non-sticky pans which are added, coated. That is the solid lubricant. Okay, and semi-viscous, grease. We all know that. We have seen that. Big trucks, JCBs, earth movers. All these will be, and giants wherever there is a jacks. This hydraulic movement. There is a application of this kind of semi-solid lubricant, and whenever there are non-sticky cooking wares in utensils, this kind of graphite and molybdenum sulfide disulfide coating will be there. Okay, now substance which reduces the friction between two moving objects is nothing but lubricant. From the beginning we are talking about it. Commonly used solid lubricants are graphite and molybdenum disulfide and graphite. Graphite, let us see something detail about graphite. What is graphite? Hexagonal structure. Okay, hexagonal structures are layer by layer stacked. They are held together with weak van der Waals forces. Okay, hexagonal layers are held together with weak van der Waals forces. And it is the hexagonal structure is nothing but monolayer, single layer connected with another monolayer connected with another layer, and that is the structure here. Graphite. The carbon to carbon distance in the benzene is 0.14 nanometers, whereas the distance between layer 1 to layer 2 is 0.34 nanometers. What is the distance between monolayer to secondary another layer? 0.34 nanometers. And combining of these graphite layers held together weak van der Waals forces. Okay. These forces facilitate easy sliding of one layer on the other layer. Which forces? Weak van der Waals forces. Helps or facilitates easy sliding. So lubricant should have the sliding property, right? So here easily sliding of lubricant is due to weak van der Waals forces. Okay. And it is used at high temperature. What is that? 450 degrees centigrade. Such a high temperature. At such 450 degrees centigrade, our lubricant should be stable. It should not evaporate. Okay. Now, here we can see another example for the solid lubricants is molybdenum disulfide. Sandwich-like structure in which hexagonal layers of molybdenum lies between two hexagonal layers of sulfur atom. Here it is the example. This is one layer, this is another layer, sulfur layer, molybdenum layer, sulfur layer. There are two sulfur layers. There is a molybdenum layer and another sulfur layer. So hexagonal layers of sulfur and molybdenum are held together again with the van der Waals forces. And these van der Waals forces are the responsible for sliding nature of lubricant, and this can be stable at high temperatures such as more than 400 degrees centigrade. This is the graphite. Now, there is a mechanism for the lubrication. What is the mechanism? There are three types of mechanisms of lubrication: hydrodynamic or fluid or thick film. Thick means huge. Thin means very small. Okay. So thin film lubrication, thick film lubrication. Apart from this thick and thin film lubrication mechanism, there is third one, that is extreme pressure lubrication mechanism. Now let us see in detail what are these. Hydrodynamic or fluid film or thick film lubrication mechanism. Now you can see here there are two objects. This upper one is A, the bottom one is B. There are two objects, right, which are in contact and moving moving together. Now the gap here is 1000 angstroms. 1000 angstroms means 100 nanometers. So now let us see the gap between A layer to B layer, or object A to B, the gap is somewhere 100 nanometers, which is in terms of angstroms it is 1000 angstroms. That's why we are calling it as thick layer mechanism or hydrodynamic lubrication mechanism. So what is the thickness between object A and B? How much lubrication is taking place? Around 1000 angstroms, which is nothing but 100 nanometers of thickness lubrication is taking place. That's why we are calling it as thick film lubrication. Now, the coefficient fraction of is low as 0.01 to 0.3 angstroms, and this ultimately reduces the friction. What are the examples for this thick lubrication? Hydraulic jugs, oil brakes, car, truck, tractors, very heavy vehicles will be having these oil brakes and hydraulic jugs. Tippers also and tractors. These are the examples for thick film lubrication mechanism. Okay. Now, second mechanism is boundary or thin film lubrication, TFL. The thin film layer of lubricant is adsorbed, not absorbed. Absorption, bulk phenomena. Adsorbed, surface phenomena. So lubrication is happening on the surface of any moving object. On the metallic surface due to physical and chemical forces. Lubrication, boundary or thin film lubrication is adsorption based lubrication mechanism. It has been happening through physical and chemical forces only. Okay. Now, what is the coefficient fraction? Is low as 0.05 to 0.15 angstroms. And now, solid lubricants, grease, oil with proper additives as lubricants in thin film lubrication mechanism. What are the examples? Graphite, molybdenum disulfide and mineral oils. Here we can see there is a surface A, surface A, surface B. See, surface A has been, whatever this dark portion is there, okay, surface A and B are coated or applied with the oil. For example, when we do body massage with by applying the oil, if without oil, if we rub our hand or any body part, what will happen? Heat generates and it irritates. Okay, but when we take the oil and rub on our body, what will happen? We won't feel irritating or heat generation. Similarly here, object A, whatever the green part is there, that is the grease or wax or lubricant. Similarly for the object B, what is the thickness? It is somewhere 10 nanometers, 10 to 20 nanometers thickness of the grease. That is why we are calling it as a thin film lubrication mechanism. So very less. If we apply the oil on our body, what will happen? Very thin film will be coated. The thickness is negligible, or somewhere 10 to 20 nanometers oil layer on the surface of our body. So that's why we are calling it as a TFL. TFL is nothing but thin film lubrication. Now, third one is EPL. EPL is nothing but extreme pressure lubrication. What is extreme pressure lubrication? When moving surfaces are under very high pressure and speed, high local temperature is attained, means generated. Under such conditions, a lubricating oil fails to stick and may decompose or vaporize. Okay. Extreme pressure lubrication, we need some special lubricants, special grease. Why? Because high pressure and high speed and high load is applied. Okay. So to avoid the friction at such high speeds, at such high loads, at such a high pressures, we need some special lubricants. And to avoid these extreme pressure conditions, special additives called extreme pressure additives, mineral oils, has been added to the lubricant oil. Here we can see the pictorial representation. The important extreme pressure additives or organic compounds contain active radicals or groups such as chlorinated esters, sulfurized oils, triglyceryl phosphate. These are the additives. With these additives, that lubricant oil is sustainable at such high pressures, high loads and high speed of moving objects. Okay. These additives react with metal surface at high temperatures and pressure, producing more durable film between two metal surfaces capable of withstanding very high load and atmosphere. Okay. So these are the chlorinated esters, sulfurized oils, triglyceride phosphates should be added to the lubricating oil to overcome the high pressure, high load and extreme speed conditions, to avoid the friction or damage of machinery. Now, there are some properties of lubricants. What are those properties? Viscosity, cloud point, pour point, flash point, fire point. We have 5 properties of lubricants. First property, what is that? Viscosity. What is viscosity? Viscosity is the property of fluid that determining the resistance to its own flow. Okay. For example, there is a cooking oil and there is a coconut oil, and third one is glycerin. All are in the liquid state. Coconut oil, cooking oil, glycerin, all are in the liquid state. Do you think all the three are having same flow? No. Whereas cooking oil flow is different than the coconut oil flow is different from the glycerin. Though all are in the liquid state, based on their viscosity, their flow is different. Okay. Now, it is an indicator of flowability of lubricating oil. So, viscosity. So, measuring or determining property of a lubricant. That is, the lower the viscosity, greater is the flowability. Okay. For example, water. What would be the viscosity, low or more? So, lower the viscosity. Why? Because water flows easily. Water flows easily means it is not so viscous. Its viscosity is less. Okay. Now, viscosity helps in the selection of good lubricating oil. Yes. The lubricant property, that is whether it is a good lubricant or not, can be decided by property called viscosity. Okay. Heavy oils are used on parts moving at slow speeds under heavy loads. Viscosity can be measured by viscometer or rheometer. Okay. Now, another property is, in order to understand the suitability of lubricant in cold conditions, we make use of cloud point and pour point. Yeah. Cold conditions. So, to understand the viscosity or lubricant property in cold conditions, we have two properties. What are those? Cloud point and pour point. What is the cloud point? Tells us the temperature below which oil cannot be used as lubricant. And cloud point indicates the tendency of oil to plug filters or small orifices at cold operating temperatures. Okay. Now, last one, flash point and fire point. Flash point of an oil may be defined as the lowest temperature at which it gives off vapors which will flash if brought into contact with flame. I will tell you one example. We generally don't turn off all the time nozzle of our petrol and it will be keep on going from tank to engine, and there will be a petrol or diesel deposition in the engine from tank to engine. Okay. So, when we do the ignition or kick start, when we do the start, what will happen? Whatever the deposited petrol or diesel is there in the engine, that will burns all of a sudden. That is nothing but your flash point. Fire point is the temperature at which lubricant combustion will be sustained. Okay. For example, we are operating a car. Whatever the temperature generated after 100 kilometers, the same temperature or more or less same temperature will be there for after 200 kilometers also. So, here fire point is telling us sustainability of our lubricant at prolonged usage. Okay. These are the properties. The fire point of an oil is defined as the lowest temperature at which it will give enough vapors which on rising will begin to produce continuous flame above the oil for at least 5 seconds. Okay. Yeah. These are the references for this engineering materials or smart materials module. Okay. First reference is engineering chemistry by P.C. Jain and M. Jain, published in 2010. Engineering chemistry by Ramadevi, Venkata Ramana Reddy and Rath, 2016 published one. A textbook of engineering chemistry by Tirumalachari, published in 2011 and 21. Textbook of engineering chemistry by Jayasri Anireddy, Willy Publishers. Engineering chemistry by Sikha Agarwal, Cambridge Press, Delhi, published in 2015. Thank you very much. And next class we will meet with other topic. Yeah, thank you.